actually see. We are seeing some attacks on users and on the user accounts, and this is what I would like to talk about today. We have some insight because of the number of eShops we are actually using and we are running and we are operating. We see some things going on. I don't have the exact number of the users we have. I don't really think it's actually important because the number also changes. Some of the eShops, they have like 2 users, but there are some eShops that have like 100 users. I mean, when I'm talking about users, I'm not talking about their customers. We don't really care about that much. We will see that later. When I'm talking about users, I'm talking mostly about the owners of the eShops and the administrators of the eShops. I will get back to that later as well. So one of the typical and classical attacks is a password reuse. When users use the same password, this is what Max was talking about before. When users use their password on a site A, the password leaks from the site A, but they are also using the same password on site B. This is a typical attack where users are reusing their passwords. It's not just regular users, it's also users that should know better, I guess. Like, for example, this Mark Zuckerberg dude. He was reusing his password on LinkedIn, but he was also reusing the password on Twitter and Pinterest and all the other companies he doesn't own, I think. The password was da-da-da, and I think Per was mentioning that if you see someone's passwords, you can actually say something about that person, right? Exactly. I mean, let's talk about Russian influence, right? But not today. So yeah, seeing some of the passwords, they are like really interesting, and you are like getting into that person's head, and sometimes it's not that nice. So I also stopped doing that because you see things that you don't want to see. This also goes on for many users, and Max was talking about that the users don't change their password. I would love to try if Mark has changed his password. I don't know. I haven't tried, but we also see some databases leaked in 2017, which is like 9 years ago, 8 years ago, and users are still using the same password, even if the database has leaked 8 years ago, and the company has actually issued a warning and they have advised their users that they should change their password. Maybe the users did change the password, but not at the other sides. So we see, databases from 2017. They are still the passwords are still active. So this also goes back to password rotation. I mean, sometimes it would sort of make sense because if the user is using the password from 2017, I mean, maybe. And it was actually breached, the password was leaked, and it's actually compromised, like 100% compromised. Maybe they should change it. But so in general, password rotation, I'm not going into that right now. There's a lot of databases that that are being leaked on the internet, that they are already available, and that you can use to do some stuff that we will be talking about. If you go to this Have I Been Pwned site, I guess, please raise your hand who has not heard about the Have I Been Pwned site. Okay, cool stuff, I expected so. So if you go to the Have I Been Pwned site and you will list all the sites that have been breached and you sort it by the number of accounts that have leaked, you see these 2 lines. One of them is the quite recent Cynthian credential stuffing thread data with 2 billion rows, and the other one is a collection 1 with 700 million, well, quite a huge number. I don't even know how to say that in English properly. So these data are actually readily available. You can download that. You don't need to even pay for that. One of the things I wanted to say right now is that when we are going through some of the leaked data, I have never paid a single dollar or a single cent for the data. I don't want to support criminals in general, and I don't want to support these guys. So when I'm talking about the leaked data and that we are actually going through some of the data, we haven't paid, or I haven't paid a single cent for the data. You can download it from the internet if you know where to look, and we can then talk about it later. The numbers are quite huge. You'll quite often see in the news that, yeah, there is a new leak with, I don't know, 2 billion, 3 billion accounts and blah, 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 these kind of numbers. And if you look at, the data sizes that will actually, that you can download, they are quite huge. This is an advertisement, sort of, for some of the, for the collection one collection. It's usually a collection of dumps gathered from multiple sources. So this is the advertisement for the collection one data set, and you see the numbers like, okay, 87 gigabytes, 500 gigabytes, 37 gigabytes, and these are actually just text data, usually compressed, but it's text data. It's not binary. It's just usernames and passwords. The numbers, which are actually readily available, are really huge. So. Then the attackers take the database and they try to log into the sites that they are actually present in the database, and it works quite often. What we have seen lately, like during, I don't know, let's say last 2 years, is quite a, I don't want to say new thing, but sort of maybe, is that we have seen that some of the accounts were taken over, and the bad guys did things like install a fake payment gateway, which if you want to pay for the products you have in your card when you want to buy something, that the site will actually present you a fake payment gateway, and then they will steal your credit card number. Because the bad guys has actually, they have gotten into the admin of the eShop, and they have changed the HTML code, and they can do stuff like that. What we have also seen is that the attackers have changed the account numbers. In some users, when they buy stuff, they want to pay by a bank transfer for some reason, and the eShop will then send them a different bank account number than the original one, so they will actually pay, they will transfer the money to the bad guys. This is also quite often what we have seen, and quite not a nice thing. But another thing that we are seeing, and when we were actually trying to research or recover from those attacks, then we have seen that those were the accounts that were not present, for example, in these kind of databases. We went to this Have I Been Pwned site, used the email address of the owner of the eShop, and they were like, yeah, 0 breaches. Like, yeah, there is no breach for this account, but like we are actually seeing that somebody is using the password to get into that eShop, to get into the administration of the eShop, and the login is, for example, I don't know, from West Africa or some strange places for a Middle European country, for a Middle European company, and so this must be breach. There must be something going on. What we are seeing lately is that data from malware called information stealers, is actually being distributed over the internet quite freely, and the bad guys are using these data. This is fresh data, sort of fresh data, and they are reusing these leaks from the malware, and they are trying to log into the sites as well. So let's talk a bit about the malware. Information stealer malware, the only purpose of the malware is to actually, steal information. And it's doing quite well, and it's doing so well that the malware operators are actually selling it as a malware as a service. So if you got some money, you can buy malware, like readily available distribution, and then you can, hack some other people if you want to. It's just business. I mean, just business. One of the most probably common malware is called Luma C2. This is you can just you can reuse it if you want to, if you pay some, I don't know, $1,000 or something like that. And many people are actually doing it. Now, You may be asking, like, how come that people will actually download the malware? How come that they will install the malware? Because it must be obvious. It must be, they can't do that. But actually they do, and quite a lot. The attackers are actually exploiting sort of psychology, and they are trying to get the users to install the malware, and they are trying several schemes to do that. One of them, they are trying to exploit us, humans, because we like to solve problems. We solve problems every single day. One of the problems is called CAPTCHA. We are used to solve the problem. The computer is like, hey, can you prove that you are not a robot? And I'm like, yeah, I will try to find a bus, for example. This is one of the CAPTCHAs. It's quite small, but one day I was presented a CAPTCHA, please find the bus. I was like, yeah, it's there. It's just, the whole thing is a bus. So it was kind of depressing. But we are used to solve problems every single day. It's like, yeah, find the chicken, find the bike, something, and we do that, okay, and the computer is happy. What the attackers have started to abuse is this fact that we like to solve problems. They have come up with an attack that's called click fix. They were like, yeah, please tell us that, or please prove that you are not a robot. So you click the checkbox, and then they will present you with another screen that says, to finish the verification, please press Windows R, which opens a command line, then press Control V, which pastes something, and then press Enter, which runs the command. This is called click fix, and we see that it's happening quite often. And by clicking the checkbox, the website will copy something into the clipboard of the user, and then they will paste it into the command line and they will run something. Usually it's a PowerShell command that will download something from some other site and that it will run it under the user. We see that this is happening quite often. Why do we know that? Because when going through the data from the info stealers, my own antivirus is like, hey, I found something. This is what I see quite often. The antivirus is like, hey, I have found a threat that something's going on your computer. And when I looked at the file, it says that the threat has been found in a file called autofill.txt. I'm like, what? You can put viruses in forms or something? And when I actually opened that file, you see that it's a PowerShell command to download something from somewhere and then to run it. And this is what I see quite often. Like you see the history, like almost every day, I see that when going through the leak data. There are other ways how to infect a user. For example, users do not like to pay for software, right? So they download cracks for Photoshop, for other tools as well. And the cracks, they try to be helpful. They give the instruction to the user like, hey, turn off your VPN, if you have one, so that we know your IP address. Then you can install this crack by unzipping and choosing a directory. Please disable your antivirus. Do that. So users will do that because they don't want to pay for Photoshop. Run the setup and then enjoy. Of course, enjoy. And then there is a nice instruction. This is a copy-paste from some of the cracks. I don't remember which one right now, but this is a copy-paste from the instructions. And it says, important, if you do not have 7-zip or WinRAR archiver, we have taken care of you. You can run the installation file, which has been bundled with the crack. It's called WinRAR, blah, 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 which is probably also a virus, I guess. Users also like to try to be hackers, so they try to download software that's called spoofer or some, cracks, hacking tools and things like that. When these kind of tools are advertised in some of the Telegram channels, for example, users are like, yeah, I will download that. So they download a spoofer.rar. When I tried that and tried to open it, my antivirus was like, don't do that. It's of course a virus again. So people will install the malware like. They are doing that every single day, and it's quite a lot, quite often. And then the malware, the info stealer, will steal data. What kind of data does it steal? This is an archive from one of the info stealers. They like to call it logs. If you are building web applications or different applications, you are also logging some stuff. You like logs. And the attackers also like logs, different kind of logs. This is an archive from one of the malware, and if you check that, they have it quite nicely sorted. You have folders for applications, for cookies, for I don't know, sometimes credit cards, and you have files called allpasswords.txt and software.txt, system.txt. Every single information about the compromised computer is there. They will just sort of siphon it out. They will take all the information, they will package it then, and then they will distribute it. They will also try to steal your cookies. Stealing cookies is quite easy because the cookies are usually in a file on the computer. It's an SQLite database, so you can query it quite easily. The cookies are not encrypted, and even if they would be, it's usually an operating system key which can be used by the malware as well. So it's quite easy to steal cookies. But we are not talking about cookies much. We would need to organize a cookie-con. It could be in Cork, cookie-con Cork. So, but the malware is also stealing cookies. And cookies are often used for authentication. If you go to a site, you enter your password, and then you enter your 2FA code, and then there is a checkbox, please remember me for 30 days. This is also using cookies. So what the attackers are doing, they are bypassing 2FA by stealing cookies. They just steal the remember me cookie, and they don't need to steal your 2FA generator. But sometimes the malware is also stealing the 2FA generator secrets if it can. If the users are using let's say, browser extension for generating 2FA codes, it will just steal the browser extension settings as well because it can, so it will do that. The information in the logs is quite interesting because sometimes you see in some cases, you see how long the malware has been running on that computer, where exactly is it on that computer, what kind of CPU does the computer have, what's the memory of that computer, and things like that. So right here, it's a computer running somewhere in Czech Republic, and you see on the highlighted line that the malware has been running somewhere in the temp directory, and someone has tried to download a mod menu loader something. I have then Googled that it's something for Minecraft. I don't know exactly, but users like to play games, so they will download something off the internet from random places, they will run it, and blah, blah, and ta-da, it's a malware. Some other users, in other cases, we have seen that some users have the malware running on their desktop, actually on the desktop. So imagine you are looking at your computer desktop and there is a file called 2ngr7eqd.exe and you are like, yeah, that's fine. They have it running on the computer, and also it's a Windows Enterprise, so it's probably a corporate machine. You are like, yeah, whatever. I mean, that's fine, right? Running it on your desktop. And also, some of the users have the malware for years, and they're like, probably that's also fine. We don't care about that. Then, talking about the logs, which I have seen, the archives, they are being distributed, and the file sizes are quite huge. For example, this is one of the distribution archives that you can download from somewhere, and it's 70 gigabytes, and it's actually packed. It's a zip archive. So if you unpack it, it's roughly about 200 gigabytes of text data. And you can download this amount of data almost weekly. So this is crazy amount of data. And it's a bonus, so it's called a bonus file. So you also get regular files, which are slightly smaller, but they are being distributed more often. What the attackers are also doing is that they are extracting only the password information from the archives, and they are distributing it as a ULP file. ULP stands for URL login password, which is only a file of many lines where you have the URL, login, and password. And if you check the file size, this is crazy. It's 700 gigabytes unpacked of just lines of passwords. You can download it as well. It's somewhere on, I believe this was gofile.net somewhere. I haven't even heard about the storage, but I have downloaded this file as well. So this is the data that's readily available on the internet that you can use, that the attackers can use, and that the attackers are using as well. What we see that it's not just the primary hackers. I mean, it's not just the hackers that will compromise the computer, but it's also some other users that will download these files and they are trying to, hack the other users for some financial advantage as well. So it's also these redistributed archives that are being used. Now, this is the landscape. It's pretty dumpster fire-ish, and this is what we are dealing with. But there's also something that we can do with this kind of stuff, and this is what I want to talk about right now. When I'm talking about we, I mean it's a teamwork. I cannot do it alone. It's a teamwork of multiple people in ShopTet that they are helping me with that. I have two of my friends and two of my colleagues here, Pavel over there and Vojta. Wave. Pavel is back there, Vojta, thank you guys. And they are also helping me. They are not part of my team, they are not part of the security team. I like to call them terrorist cells. Well, a C-level management doesn't like the term. They are like, so you mean ambassadors? I mean, no, I mean really terrorist cells. But they didn't like the term. They are working in different teams, but if I need help, which is pretty often, they are trying to help me with stuff like this, and they are also building some tools. So this is a teamwork across the whole company. So thanks. What we are trying to do, let's talk about that. One thing I want to be clear about is that we do not care much about the end users. By end users, I mean the users that are actually buying stuff from the shops. The reason is that we do not see attacks on these end users. We do not see that. I mean, of course, they are going on. There are attacks on these users, but there is nothing interesting for the attackers. So we don't see reports of those users being hacked. Not a single report directly. They are hacked indirectly by the fake payment gateways and by the fake account numbers, but direct attacks we do not see that. There may be also a reason for that, and that's because users do not create accounts. If they can buy stuff by just filling their address, email, and the delivery address, they just do that. They do not create accounts. We have checked the number of put it this way, authenticated requests where users are logged in versus the requests where the users are not logged in. The number was, can you guess what was the number? What was the ratio of the requests in general per all the sites? What the ratio of logged in users versus not logged in users? Who think it was like 50%? Who thinks it was less than 50%? A less than 50% ratio of logged in versus not logged in requests and users. The number was 2%, and the number is 2%. So users do not create accounts, which I do not understand. I create a lot of accounts because I like to have accounts, I like to have passwords, and I like to see how it works. But users do not do that. It's 2% of, that was like, it's a ratio of requests. So if you go to a site and you are logged in, you fall into those 2%. If you go to a site and you are not logged in, and it's, those 99%. And this is without bots. The number is without robots trying to do something with those sites. So we are mostly focusing on admins because they have some administration privileges on the sites. They can change account numbers. They can, they can delete users. They can create users. They can edit the HTML of the site a bit. So we are mostly focusing on those because we see attacks going on the admins. This is our login screen. No, not login screen. Sorry. The account registration screen in the admin, or a password change screen, where you can change your password if you are the admin. There may be one interesting thing that you may notice, and it's the minimum character count. It's 4. It's very legacy. It was ShopTet was actually first created in 2013, I think, or 11, something like that. And this is a legacy thing, and I think it's still there from the day one. and the number is pretty low. We will need to change that. We will definitely need to change it, make it a bit higher. But what we are seeing that this is not actually a problem. The user accounts are not being hacked because they have four-character password. They are being hacked because the password is being reused or because it's stolen by the malware. We do not see accounts. We do not see attacks that the attackers are trying to, let's say, log in with password 1234 or something like that. We do not see that. So we have prioritized, when working in a company, you need to prioritize. So we had prioritized a different thing of protecting the users, because if we would change just the number of characters to 8, we would still see the same attacks. It would be still the same thing. There would be no change. Also, the password strength estimator we are using, it says good, but the password behind the dots is password 1. So it's not really good. We need to change that as well. We will do that. I'm not sure when, but we will definitely need to do that. Probably with the regulations like NIS2 and things like that, we will need to change that because we would need to be compliant with those. But again, for us, it's not a real problem. You can use a password strength estimators like ZXCVBN, the Dropbox one, that will actually give you a better estimation of how good the password is. But to use this kind of estimators, it would require quite a lot of work to create some of the dictionaries it is using and things like that. So we have done a different thing. We have prioritized a different thing, and that it's trying to see if the password the user is using, or if the password the user is trying to set has been already seen by the Have I Been Pwned service. In other words, if the user is trying to set a leaked password or a compromised password. There is an API, Pwned Passwords is an API that you can use to check if the password has been leaked. You send first 5 characters of the hash to the service, and it will return back a list of the hashes. So you compare it. If the hash has been already seen, then it means that the password is known by the service and it's a compromised password. It has leaked already. The number after the colon is in the highlighted line below, is the number of times how often the password has been seen by the service. You see that password 1 has been seen quite often, but we have made quite a strict decision that if the password has been seen at least once, we do not allow the user to set it. I mean, we are talking about the administrators, right? So they have some privileges and we need to be quite strict with them. So if the password has been seen at least once, if it has leaked at least once, we do not allow the user to set it. We also notify the user if they log in with the leaked password, we notify them that, hey, you are actually using a password that has leaked. You should change it. We cannot block the account right now at this stage, because we are not sure if the leaked password has leaked from the user who is trying to log in or from somewhere else. So we just can notify the user that, hey, you are using a password that has leaked, so you should change it. This is, and we are the minimum character count for right now means that probably every single password, every single short password has already leaked. So even if the user is using the password, let's say 1234, they will get a notification that you are using a very weak password anyway. So we don't really care about the minimum character count, because this is doing much better service for us. That it's real data, it's real leaked passwords, so the users are getting like real life information. We have also learned to love these kind of data, these kind of attacks, and this kind of data that is being distributed and you can download. We are trying to use this kind of data to also protect the users. In the file, if you extract it, for example, or if some other files, you get these URL and login and password, and delimited by colon, and we are trying to use this information and see if we have this, I don't know, let's say threat example.com user in our database, And if we do, then if this kind of threat guy, if Fred has the same password that has leaked from somewhere. Because right now we see that Fred has been trying to log into example.org with a password. And we check our databases if we have Fred example.com account, and if we do, then we check if we have it with a password. And if we do, then we actually log the account. At this stage, we can log the account because this is like, we are 100% sure that the password that has leaked is from this Fred guy. So we can log the account and require the user to reset their password, and then they need to reset the password, yes. This is something that we are working on right now, trying to go through all the gigabytes and terabytes of data and try to find the users. It's an ongoing project. We need to do that like constantly. It's not just that we will run the checks once, but we need to do that constantly. And we need to download data constantly as well. The problem with the data is that the hacker guys, they are not doing our jobs easy. This is there are multiple formats used by the hackers as well in the file. So Pavel over there, his parsers needs to be really good ones, and he's not really happy with those hacker guys because sometimes the delimiter will be space, colon, space. So your parser needs to handle that. You need to strip the spaces. And sometimes they are using pipes instead of colons. So you need to also take care of that. And there are like 14 other standards. And what I've seen lately is that they have been so proud that they have introduced a new standard of this ULP password lines. And they have prepended a country name or country code in front of the URL. And they're like, yeah, this is the best format ever. So, okay. So your parsers need to handle that as well. And we are trying to do that. And when I say that we are trying to, we actually need to do that, or we should do that, because there are some regulations and some guidelines. Thanks, Jim, I guess. There are some guidelines and some regulations and also some laws that we need to actually do that. For example, NIST guidelines, they say that password verifiers, which is us, we are verifying some passwords, they shall force a change if there is an evidence of compromise of the authenticator. If we have 700 gigabytes of data, the evidence is pretty strong, I would say. Also, PCI DSS, which is regulating or which is data security standard for payment cards. This data security standard says that authentication policies and procedures are documented, and instructions to change passwords and passphrases if there is a suspicion of knowledge that the passwords have been compromised. We have not just a suspicion, we have the data, so we know that the password has been compromised. And also the NIST directive, Network Information Security Directive, which is a European thing, which has been translated, incorporated into local laws. It says that the obligated person shall further ensure that the password is changed immediately in the event of reasonable suspicion of its compromise. Well, a reasonable suspicion, we have data, so we know for sure that the password has been compromised, so we need to actually reset the password. We need to do something with that. I like how these laws and directives do not actually talk about the source of your suspicion, to put it this way. They do not talk where you get the data. Well, it's not their job, and it's pretty cool. One of the things that we had to learn when doing these kind of projects is how we talk to the rest of the company, because this project is not a secret project. I mean, CTO knows about that, and legal department knows about that. But when I came to our CTO and I told him, like, hey, we have a database of stolen passwords. We want to do something with them. It was like, hey, is there any other option? Because stolen passwords doesn't really sound quite good. So we have, and I didn't even go to legal department and trying to say, hey, we have a database of stolen passwords. They would be like, oh, get out. So we have changed how we are trying to call those. We do not call them stolen data, stolen passwords, even if actually it is most probably stolen passwords. We call them a compromised passwords, because that's what we are using it for. That's our motivation, how to use those kind of things, so we call it this way. This has actually helped us quite a lot when talking to legal departments, because they're like, yeah, this is a good idea. This is crazy. Yeah, do that. We will help our users, and that's, I don't care where you get the data. I'm like, okay, we will do that. When I was talking about cookies, that's another problem, but let's talk a bit about that. The malware is also stealing cookies, bypassing 2FA, and the malware, in most cases, in some cases, doesn't even need to know your password, because it has the authentication cookie or session cookie, which sort of identifies you for the web application. There is a new technology called BDSM. Oh no, sorry, DBSC. It's similar thing, I guess. It's called device-bound session credentials. This is a technology that should help with, that should stop malware stealing cookies. It would be still able to steal cookies, but the cookies will be really, the lifetime of the cookies will be really short. If the malware steals a cookie that's with a lifetime of a year, then the attackers have a year to actually use the cookie. But if the malware steals a cookie with a lifetime of 10 minutes, by the time the cookie gets to the attackers, the cookie is already expired, so it can't be used. DBSC is not a replacement for cookies. It's an add-on for cookies, or add-on for the authentication flow. So let's see how it works in details. So your browser needs to support this DBSC thing, and your server, the web application server, also needs to support this kind of authentication flow. But the first step is that if your browser tries to sign in, the server, if it supports DBSC, it will respond with this session registration header and a cookie with a lifetime of, let's say, a year, with the original cookie that's with a long lifetime. If the browser doesn't support DBSC, if the browser doesn't support this, then it will use the cookie with a long lifetime and will work just like regular. But if the browser supports the DBSC device-bound session credentials, it will do this. It will generate a private and public key, and it will start the DBSC session with the server. It will send the public key to the server, so the server will register the public key for the current user, and it will respond with a new session cookie with a short lifetime. The set cookie header then will have a new session cookie with, let's say, 10 minutes lifetime, really short cookie. So if the malware steals this one, it's really useless for the malware. And then again, the browser will use the cookie to authenticate to the server again, and the server will just send the content back, and the users are using the application as normal. It's just they don't see anything different. But if the cookie expires, after 10 minutes of usage, if the cookie expires, then the browser will automatically try to refresh the cookie with the server. This is the last step right now. So the browser will then send the server that, hey, session ID, this cookie, this session ID has expired. I need a new one. The server will then respond with a challenge, with a string, with a random string, with a challenge to the browser. The browser will sign the challenge with the private key that has been generated in the first step. It will sign the challenge with the private key, and it will send it back to the server. The server will then verify that it has been signed with the key that has been stored in the second step. It will verify that it is talking to a sort of known browser. It will verify the challenge, and then it will issue a new cookie. It will issue a new cookie with a short lifetime. So instead of using like cookies with a year that will expire after a year, then we have short cookies, and those short cookies can be still stolen by the malware, but they will be useless for the malware operators. Good news is that the browsers will support this really soon. Chrome will support it in 145, in version 145, which will be released in a few months. Right now, you can already use that, in origin trials, in, for example, Google Workspace, there is a checkbox, use DBSC, so the authentication will be more secure, and you can already use that. But of course, if the users will install the malware, or install a malware still, then this first of 10 immutable laws of security, it still applies. I mean, if a bad guy can persuade the user to install or to run a program on the user's computer, it's not solely the user's computer anymore. The malware operator can do stuff with the computer because it's also kinda the malware operator's computer as well. It's under his control, under their control. So they could, they wouldn't need to steal cookies. They can, for example, proxy their requests or do stuff like that. The DBSC technology is sort of reactive way of trying to do something with the attacks that we are seeing today. It might not be future-proof, but we will see. And there are also some other laws of security which do apply here. And that is, if the website operator allows a bad actor to run active content, let's say JavaScript on the website, it's not just the website operator's website anymore. And weak passwords trump strong security. So if the users would be still using the weak passwords, then we can do whatever we want, but it wouldn't be enough. So I really hope that the BSC thing will end the cookie stealing attacks, and I'm looking forward to some other new attacks because we definitely see new ones. So yeah, we are looking forward to the future and see what's going on. And of course, the AI put the lock on some stupid place in this image. So this is the future that we will be living in. Okay, that's it from me. Thank you very much, and have fun with cookies and stolen data.